everybody, this is your parallelogram, area of parallelograms video. Make sure your notes are out in front of you, and make sure that you are taking down whatever notes you see on the screen that are not on your paper. That is your homework assignment. Make sure that is happening. All right, quick reminder of what parallel means first. Parallel, I think of the two lines in the word parallel. They're lines that keep going in the same direction, and they never get closer together, and they never get farther apart. That's what parallel is. A parallelogram could look like this, and a parallelogram has opposite sides parallel. So in this case, we could say the left side and the right side are parallel, and we could say the top and the bottom are parallel. So a parallelogram has opposite sides parallel. So take your visual here. Parallelogram. Okay, so we're going to find area of these. So make sure your notes are ready. Here we go. So to find area of parallelograms, the formula is actually the same. We're going to use that same base times height, that same length times width, whichever one you like better, that's what we're going to use. So remember now, the area is the inside. So there's your visual of the inside. And here we go. So we're going to label this first so we know what's what. The base could be on the bottom or the top. This could also be called the length. Okay. These are just called the sides. Notice this. This is a side here, and this is a side. I don't see any S's involved up here. So must be, if I don't see any S's, I must not use these. Interesting. What do we use then? Well, if we want height, which we do, we want this height up here, we have to have, or we could call this width. This could be the width also. We have to have this right angle. Some of you have talked about this already this year. We have to have a right angle. That means that this dotted line is going to go straight up from this horizontal base that we have here. So a right angle is 90 degrees. And the only way we can find area is if we have the height. So the height can be here, or the height can be on the outside like so. The reason for that is this dotted line really even there? It's not. The dotted line just tells us how far it is from the top to the bottom using that right angle, or over here from the top to the bottom using that right angle. Why is it so important we need a right angle? If someone's measuring how tall you are, we don't want you like this side here. We don't want you leaning up against the wall to figure out how tall you are, because you won't be as tall as you're supposed to be. We tell you to stand up straight. We tell you to create a right angle with your feet with the floor. So think of your heel right here. Your heel would be the right angle. I don't know where that came from. Why can we use the same formula? Well, what I can do is I can take this triangle, I can cut this triangle off, and I can place it over here, and watch what happens. If I put it there and I take this one off, I've created a rectangle. This was our formula for area of a rectangle. Now we have a rectangle. So, started with a parallelogram. We took the triangular part off and we added it to the other side, and it gave us a rectangle. So that's why we can use this formula. Feel free to go back if you need to. All right, we're going to actually try this. So pay close attention to the funky little animations we've got here. I would like you to, first of all, make sure you're using the proper steps. Yeah. And I'd like you to stop the video and find the area of this parallelogram. So my formula is base times height. I substituted in the 12 and the 7. Notice the 7 is in there because this is what's created with the right angle. This is the height, not this. This 8 is just a side, doesn't count. 12 times 7, I'm going to do 12 times 7 efficiently. I'm going to use my brain here. I'm going to say 12 is really just 10 plus 2. And now I'm going to multiply each of those by 7. So 7 times 10 is 70. And 7 times 2 is 14. If I put the 7 and the 14 together, there's my final answer. Notice that I have A equals. Notice that it is square units. Very important. All right, let's try the next one. So you can stop the video and try this one. Formula, substituting. 14 is the base, 6 is the height. Why? Because it has a right angle. Even though it's outside of the shape, doesn't matter. I'm going to be efficient here also. I'm going to say 14 is really a 10 and a 4. And then I'm going to multiply that 6 by each of those numbers. 6 times 10 is 60. 6 times 4 is 24. And everything in the green, by the way, I'm doing in my head. And my final answer then gets me 84. And in this case, we're talking about inches, 84 square inches. Again, if I'm going too fast, stop, rewind, pause, whatever you need to do. All right, the next one. Aya has a garden in the shape of a parallelogram. The area of her garden is 240 square feet. The length is 12 feet. What's the width? Well, first statement says she's got a garden in the shape of a parallelogram, so I would have drawn that. Now we need to label it. Area of her garden is 240 square feet. So they're telling us what the area is. So the area is the inside. So if that's the case, I better label this inside it. The length is 12 feet, so I'm going to label this 12. Could have done this on the top. Either one is the length. That's fine. And in this case, they're asking us for width. Well, this is not the width. This is this is leaning, right? This is not at a 90-degree angle. This, ladies and gentlemen, is at a 90-degree angle. We called that height before. It can also be called width. It means the same thing. So the question here should be, we're not finding area, we're finding width. So how do we do that? Well, this is going to be crazy. You're not going to believe this, but we're going to follow that same stinking white poster that we have in class that looks like this. So we're going to write the formula first, length times width. But look at how we're going to substitute. This is why this is so important. 240 is the A. That's the area, right? Look at area is 240. So I'm going to put the 240 where the A is. 12 is the length. So I'm putting the 12 where the L is. So it's going to look like this. So that looks different than what we're used to. So 240 was the area that went in for the A. 12 is the length that goes in for the L. The width is what we don't know. So remember in math, when two things are smushed together, that means multiply. So 12 and W are multiplying. So here's a little tidbit of info for you. We're multiplying by a variable we don't know. And do we know this W? We do not. Do the opposite operation. So in this case, we're going to divide. So 12 times, it's multiply, right? Because they're smushed. So we're going to do the opposite. We're going to divide these guys. And I'm going to use my brain. I'm going to say 24 divided by 12 is 2. So if I just add a 0 to that 24 divided by 12, I'm going to get 20. So how do I label that 20? Interesting. I'm finding width. So I'm going to label it with a W. And then I want you to notice that it's just plain feet. It is not square feet. So why do you think it's just feet? So we're going to talk about that one in class, why that one's just feet. So on the back of your paper, you have something that looks like this. You have a question about Brian, or as I like to call him, brain. So that one is for homework. And this is your area of parallelograms video.